So now that we've got the basics of CRUD down, let's refine our skills a little bit further by adding filtering to our skill set. Now we've already done a little bit of that. Filtering just basically means something like this, where we specified a particular object. We only want to operate on that one object or that one document. For example, this one where we found everything with planet name Pluto. So the filtering is always going to look the same. It's going to look just like this. There may be more fields in here, but that's pretty much it. I'll just use this as a starting point. It pretty much has the structure that I'm looking for. I'm just going to go back and change planet name. And for this query, we're actually going to find all of the planets that have a mass greater than some number. So I'll search on mass for my filter. And I could plug in a specific number here, but in this case, I want to do a range. So let's do $GT for greater than. And let's look for everything bigger than 5 times 10 to the 26th. We'll press enter and we'll get all of the really big planets. What if we wanted to do less than? So again, I'll just hit the up arrow and you can probably figure this out all by yourself. You could change the G to an L. So we've gone from greater than to less than. And just for fun, let's do less than or equal to, LTE. So now we're going to get all the smaller planets. You can see that we got the smaller planets, the less massive ones. So we got Mars, we got Earth, we got Mercury and Venus, all the planets that have a much smaller mass than the one that we put in. Going back to one of the coolest parts about working with Mongo, and that is that you can have really rich object structures and you can query them all. Why don't we take a look at something even more exotic? So this time we're going to search within this array right here, nearby stars. And I've kind of punked this out a little bit. Naturally, all of these planets are very close together. So naturally, they're going to have all the same stars. The same nearby stars are all going to be common because they're all going to be near owing to astronomical distances. But just to make it interesting, I have sort of shaved a few of them out so that we have some different kinds of data to look at. So let's see if we can find all of the planets with a nearby star where the name of that star starts with Sirius. So we got Sirius A and Sirius B. Again, I know it's a binary star. They're right next to each other. Whatever's close to A is also close to B, but that's not the point. Let's try out db.planets.find, and we'll do nearby stars, which is the name of the field we're searching on. And to look inside of that array of strings, I'm going to use a regular expression. So I'll do /Sirius. Note that I didn't put quotes around it. And then dot and then star. So that should find everything that starts with Sirius. And I'll add dot pretty to the end because it will be a longer list. And now in my results, you can see in each case, Sirius A and Sirius B are both in the list. So we actually did a twofer on that one. We searched within the array and we also used a wildcard to find both Sirius A and Sirius B. The last advanced query I'll show you is how to search by embedded objects, which means you can have objects inside of other objects just like you can in your favorite programming language. And here we see an example of it. Discovered by is an object. So it's an object inside of the planet object. So how do we find these? It's actually pretty easy. A bunch of these planets have unknown as the name of their discoverer. For example, nobody really knows who discovered the Earth because no one was around to record it. The outer planets were actually recorded. For For example, when Galileo first started observing Mercury and Mars and the Moon and Venus, he got credit. He may not have discovered all of those, but whoever did got credit. And those were basically starting in the Renaissance and going up into the 1930s when we discovered the farthest planets out. But a bunch of them, like Earth, Venus, and Mars, have always been known to humankind. And so there isn't really anyone to credit with their discovery. So let's see if we can whittle this list down. We're going to find everything where the last name of the discoverer is unknown. So for that, we'll do db.planets.find, and then we'll do discovered by dot last name, and we're looking for unknown. Easier than you thought, right? We'll add dot pretty to the end. And I clearly missed something. Let's go see if we can find it. I forgot to put the closing quote after unknown. There we go. So now this one should work. Before I hit enter, though, I probably should have called this out a little bit stronger. Note that discovered by dot last name is in quotes. So if you're doing something a little more complicated, a compound object, put them in quotes. Let's see if this works now. There we go. So we can see all of these. Saturn is unknown because you can see it with the naked eye. As with Jupiter and Mars. And I gave props to Adam as the discoverer, but I have no idea what his last name was because they had not yet invented last names. And Venus. So these are all the planets you can see with the naked eye. They have a last name of unknown. So as you can see, we have full capability to search our database and filter out records based on any set of object criteria that we care to throw at Mongo.